All right, today we're going over 5.7, completing the square. So we're going to be completing the square when we have a quadratic, right? The highest exponent is a 2 squared, and the quadratic cannot be factored. So this is going to be helpful with finding the x-intercepts or rewriting it in vertex form. All right, so let's get started here. We are going to first look at solving a perfect square trinomial. Okay, so if we look here, the left side, we should be able to notice that that's actually a perfect square trinomial. And a perfect square trinomial, we learned that that's going to be in the form of a squared plus 2ab plus b squared is actually factored to be a plus b squared. Okay, so if we look here, this can actually be, since your a is, the number in front of x squared is a 1, we can actually see that what multiplies to 25 and adds up to 10, 5 times 5 is 25, and 5 plus 5 is 10. So if we write this out, this is really x plus 5 and an x plus 5, bringing down the 36. This is actually an x plus 5 squared because we have two of these binomials, so we can write it as x plus 5 squared. We could have also used this formula here, the perfect square trinomial formula. Okay, so bringing down the 36. Now I'm going to take the square root of both sides. So taking the square root of both sides here, the square root and squared are going to cancel each other out. We're going to get an x plus 5 is equal to, the square root of 36 is going to give us two answers. It's going to be a plus and a minus 6. Okay, and then we'll solve for x. So we'll subtract 5 from both sides here, and we get x is equal to negative 5 plus a minus 6. So let's just break this up here, that's arrow, as x will be equal to negative 5 plus 6, and x will be equal to negative 5 minus 6. So 6 minus 5 is a 1, that's one answer, and negative 5 minus 6 is a negative 11, and here's our other answer. So this is solving it by using a perfect square trinomial. All right, let's get to completing the square here. So it says if one side of an equation is not a perfect square trinomial, what we just had in the previous one, you can convert it into a perfect square trinomial by completing the square. So here are the steps that we're going to use. We're going to, step 1, find b over 2. And this is when it's in the form of ax squared plus bx plus c equals 0. So your b is for the linear term. You do b over 2. You'll do b over 2 squared. And then you'll have b over 2 squared. You're going to add that to both sides because whatever you do to one side, you do to the other side. Okay? And that's going to be completing the square for us. So do both these steps separately because they're going to give us two different pieces of information. So let's try one. Completing the square. We're going to find the missing value to complete the square here. Here we go. So our first step was b over 2. So we take b is a negative 8 over 2. Negative 8 over 2 is a negative 4. And now I'm going to take b over 2 and square it. So I know b over 2, I just found that to be a negative 4. I'm going to square that and I'll get 16. So that's completing the square there. Okay, if we wanted to factor this now, we could. So this is giving us two different pieces of information here. So we have x squared minus 8x plus 16 will actually be factored to be whatever you got b over 2 as. So this will now be x minus 4 squared. So whatever your b over 2 is, that's what goes in your binomial. And whatever b over 2 squared is, that's what goes in the trinomial to make it a perfect square trinomial. And we can check this as well. Negative 4 times negative 4 is 16. And negative 4 plus negative 4 is negative 8. Let's try this one here. We get b over 2 So our b is 7 over 2 here. Okay, we can write this as a decimal if we want, but I'm going to leave it as a fraction because I think that fractions are a little bit easier to square than decimals. So then I have 7 over 2 squared. And then I go 7 squared is a 49. And 2 squared is 4. So to complete this, I would write a 49 over 4. Okay, this is to complete the square. And now factoring it, this looks like a difficult one to factor, but it's actually not because we already did the b over 2. So this is just x plus 7 over 2 squared. So whatever you got as b over 2, that's what goes in your binomial. All right, moving on here. So now we're going to be solving by completing the square. So here we go. What we're going to do is we're going to get the part that's not helping us, we're going to get that to the other side. So if we notice here, there's nothing that multiplies to 5 and adds up to negative 12. So that's why we're going to complete the square. So I'm just going to bring that 5 over because that's not helping us. So subtracting 5 from both sides here, I get that's equal to negative 5. And I left a little room for a reason. Okay, so we're going to do this in two different steps here. So I'm going to have b over 2. So my b here is a negative 12 over 2, which is a negative 6. And now I'm going to do the same thing with b over 2 squared. b over 2 squared. So I got my b over 2 already to be a negative 6. And then I'm going to square it. So negative 6 squared is 36. So whatever I got my b over 2 squared to be, I'm going to add that to both sides. So plus 36 here and plus 36 here. Okay, so continuing on, I'm going to now look at how I can factor this. All right, well 36 minus 5 is a 31. And now what I'm going to do here is whatever I got my b over 2 as, which is negative 6, that's going to help me factor this. Whoops. That's going to help me factor this. So I'm going to look here and say, okay, what multiplies to 36 and adds up to negative 12? The number that I got for my b over 2 is going to tell you what it is. So that's going to be x minus 6 squared. And if we look here, we can check it. Negative 6 times negative 6 times negative 6 is 36. And negative 6 plus negative 6 is negative 12, which is what we needed. Okay, so this was to just check it. Okay, so now we factored that by completing the square. So now we're just going to do what we did in that first problem there by taking the square root of both sides here. The square root and squared will cancel. We get x minus 6 is equal to plus and minus the square root of 31. I'm going to leave it as the square root of 31 because there is not a perfect square that goes into 31, which means we'll just leave it like that. Then we'll add 6 to both sides here. And we get x is equal to 6 plus and minus the square root of 31. And that's our answer. So let's try another one. Let's take a look at this one here. And we're going to do the same process. So the first thing is to always look at if it can be factored, right? Because if it can be factored, we don't even need to complete the square. Okay? So we're going to see if it can be factored by looking at the value of c. So the value of c here is negative 4. So we want to say, is there anything that multiplies to negative 4 and adds up to positive 4? Nope, there's not. So we're going to bring this negative 4 over. So I get x squared plus 4x is equal to 4. Okay, so now we're going to do our two steps. We have b over 2. So my b here is a 4. So that's 4 over 2 is a 2. And then I'm going to do b over 2 squared. So I have my b over 2 already as a 2. and then 2 squared is 4. So now I know I'm going to add this 4, whatever I got b over 2 squared as, I'm going to add that to both sides, because whatever I do to one side, I do to the other side. Okay, so now we will look at how this can be factored, and we'll also add this here. 4 plus 4 is an 8. And then we know that this first step, b over 2, which is equal to 2, is going to help us with factoring it. So whatever I got b over 2 as, that's what goes in your binomial. And we can check that. 2 times 2 is 4, and 2 plus 2 is 4. So it works out. Okay, so now we're going to take the square root of both sides. Here we go. Square root and squared cancel. We get an x plus 2 is equal to, we're going to break this up as what's a perfect square that goes into 8, and then everything left over. So the perfect square that goes into 8 is a 4, and 4 times 2 will give me 8. Okay, then we'll take the square root. So the square root of 4 is plus and minus 2, bringing down the square root of 2, and then we'll get x by itself. So subtract 2 from both sides, and we get x is equal to negative 2 plus and minus 2 square root of 2. And that's our answer. All right, let's see what's next. Finding complex solutions. All right, so for finding complex solutions, we're going to do this the same way, except now we're going to get a complex solution, meaning there's going to be a value that is imaginary here. Okay, so let's see what we get. We're going to subtract 36 first. So we have x squared minus 8x, and that's equal to negative 36. All right, so let's do those two steps again. We got b over 2. So b is a negative 8 over 2, right? Here's my b. Negative 8 over 2 is negative 4. And then we'll do b over 2 squared. Okay, so negative 4 squared is 16. So now I'm going to add 16 to both sides here. So plus 16 and plus 16. Okay, because that's what I got b over 2 squared to be. All right, so then we're going to factor this. So we'll just write this out as x. It's going to be something squared. We have negative 36 plus 16. That's going to be a negative 20. And then we know that this b over 2 is going to help us with factoring it. So we have a negative 4 is what goes in here. Let's check that to make sure that we got it correct. Negative 4 times negative 4 is 16. And negative 4 plus negative 4 is negative 8. So it works out. Okay, now we're going to take the square root of both sides here. So square root and squared will cancel out. We get a x minus 4 is equal to, again, here we have to take the square root of a negative value, which means, let's say, we're going to say, what's a perfect square that goes into negative 20, and then everything left over. So we're going to write this as a negative 4 times 5, and then I'm just going to rewrite this here and continue it. So then we'll take the square root of negative 4, and the square root of negative 4 is going to be plus and minus. The square root of 4 is plus and minus 2, and the square root of a negative is I. Okay, so this will give us plus and minus 2i squared of 5. I'm going to add 4 here, and here's where our complex solution is. X is equal to 4 plus and minus 2i square root of 5. And this is our solution. It's a complex solution because it has an imaginary number in it. We knew it was imaginary because we had a negative underneath a radical. All right, moving on here. So here's where it changes a little bit. So this is when the value of a is not equal to 1. So whenever you're completing the square, you have to have the value of a equal to 1. So that means that the number in front of x squared, that has to be 1. So I'm going to bring this value of 6x over, because that's the part that we're completing the square for. I'm going to leave some room. There we go. So what I'm going to do here is I'm going to actually divide everything by, move this down here. I'm going to divide everything by whatever the value of A is. So in this case, I'm going to divide everything by 5. Okay, because we want this to be a 1. So in order for it to be a 1, I need to divide everything by 5. Because then this will make it a 1. Okay, so I have x squared minus 6 over 5x is equal to 8 over 5. So now I can do my two steps of completing the square. So let's take a look here. I have b over 2. So my b, now that the value of a is 1, the value of b is negative 6 over 5. So I have negative 6 over 5 divided by 2. Whenever I divide by a number, that's the same as multiplying by the reciprocal. Okay, multiplying by the reciprocal, so I have negative 6 over 5 times 1/2. So this is negative 6 over 10. And 2 goes into both the top and the bottom, the numerator and the denominator. So I get a negative 3/5. That's b over 2. Okay? And then we'll do our other step of b over 2 squared. So b over 2 squared, I just found b over 2 to be negative 3/5. And then I'm going to square that. Negative 3 squared is 9. And 5 squared is 25. All right, so this is what we're adding to both sides, 9 over 25. So plus 9 over 25 plus 9 over 25. There we go. Okay, so now we're going to make this, as this looks like a difficult one to factor, but it's actually not going to be difficult for us because we have the b over 2, which we solved to be negative 3/5. That's going to help us solve that. So plugging that in, I get x minus 3/5, and we can check that. Negative 3/5 times negative 3/5. If we check that, negative 3/5 times negative 3/5, that is a 9 over 25. There it is. And then negative 3/5 plus negative 3/5 is negative 6/5 right here, which is what we wanted. Okay, awesome. So now we're going to add these. So we want to get a common denominator of 25. So I'm going to multiply the top and bottom by 5 here. I get a 40 over 5 plus 9, a 40 over 25 plus 9 over 25. Okay, adding those, I'm going to bring the left side down. X minus 3/5 squared is equal to 40 plus 9 is a 49 over 25. And then we'll do our last step. Then it's the same thing as what we were doing before. Okay, so continuing on. So I'm going to take the square root of both sides now. Okay, so square root of both sides. Here we go. I get x minus 3/5, because the square root and squared will cancel, is equal to, I have plus and minus. Whenever you take the square root of a fraction, you take the square root of the numerator, so the square root of 49 is 7, and the square root of the denominator, the square root of 25 is 5. And then I'm going to add 3/5, to both sides, and I get x is equal to 3/5 plus and minus 7/5. So breaking that up, I'm going to have x equals 3/5 plus 7/5, and x equals 3/5 minus 7/5. Okay, so we have common denominators already. So 3 plus 7 is a 10 over 5, which is a 2. Here's one answer, 2. And 3 minus 7 is a negative 4 over 5. And here's our second answer. That's it. Okay, last part is rewriting it in vertex form. So last problem here, we're going to rewrite it in vertex form using completing the square. All right, so we're going to do a very similar process here, a little bit different because we don't want to add anything to the value of y. So what we're going to do is we're going to complete the square for x squared plus 6x, and then we have this plus 2, which is not helping us with completing the square. So we're going to do our 2 steps again, b over 2. We don't want to put anything with the value of y because we want y by itself for when we're writing the equation. So your b is a 6 over 2, which is a 3. And then we're going to do b over 2 squared. So your b over 2 is a 3, and we're going to square that. So 3 squared is 9. Okay, so now we're going to add a 9 here. But here's the thing. We can't just be adding in values. So after you add a value here, this 9, if you add it to this side, instead of adding it to the other side, we're going to also subtract 9, because then you're not changing the equation. What you're doing is you're just canceling it out. But for this part, this is going to help us with factoring this part of the trinomial. So we're going to factor the perfect square trinomial now. So now I have, this is going to give us x squared plus 6x plus 9. I already know that whatever I got my b over 2 as, which is a 3, that's going to be x plus 3 squared. And let's check that. 3 times 3 is 9. 3 plus 3 is 6. So that worked. And then we'll have 2 minus 9, which is a negative 7. And this is in vertex form. Let's write down vertex form to remember what it is. It's a x minus h squared plus k. This is vertex form, and now it's in this form. And we know now that we have it in vertex form, we can actually say a couple things about it. We can say that the vertex, we know that the vertex is h comma k, and in this case your vertex is negative 3, negative 7, because it's always the opposite sign of whatever is in the parentheses, because it has to be in the form of x minus h. And that's it. Thanks for listening.